In this slide, we'll prove the projection of vector A onto another vector B. The mathematical notation for this operation is projection of A onto subscript B. To evaluate this projection, this is the equation. The numerator is the dot product of vector A and B, A dot B, dividing by the norm of B square. This will produce a scalar because the numerator is a scalar, the denominator is a scalar. So this is a scalar and a scalar multiplying by B. So the final resultant projection is a scaled version of the vector B because that's what we want. We want to find out what we can get out of B from A. This is the diagram that we are interested in. This is the A we are given. This is the B vector we are given. We want to find the projection of A onto V. It is this vector U here. You will realize that if we approximate A by U, there is a residual. This residual, let us draw in another color green. This residual, we call it E, the error vector. Let E be the vector A minus U. We now have two methods to prove this. In method 1, please follow this link. It is only a 5 minutes video of the proof. And in this first method, they use the cosine theta, the angle between A and B vector, to derive the projection equation. I would now present the second proof. The second way to prove is to use this equation. Let the error be A minus U. This error is orthogonal. This vector E is orthogonal to B. And we use this property to start. In a later lecture, you realize that by having orthogonal projection, the error E is the smallest. So E dot B equals to 0. This is a scalar 0. The dot product of E and B vectors is 0. We substitute E with what we define as E, which is A minus U, and we can open up the brackets. We then move minus UB to the right hand side, and A dot B equals to U dot B. We now post multiply both sides by a B vector, remembering that these guys are nothing but scalar. A dot B is a scalar, U dot B is a scalar. So we have just multiplied a scalar with the vector B. We are interested in U. What we can do is that we open up the bracket and we combine U dot B times B to be the vector U, which is a vector multiplying by a scalar B dot B. We now have U being independent, and we can shift this B dot B to the denominator, which is over here, and we finally get this equation. The vector that we want, which is the projection of A onto B, is equals to A dot B divided by B dot B times B. What is B dot B? B dot B is the norm of B square, since the norm of B is equals to B dot B square root. Please go through both ways of finding the projection of A onto B equation. Thank you.